Hello students, in this session
Let us solve a question on bending stresses. In this question, we are given with a L-shaped structure is given to us, and it is loaded with a force F at this corner. And we have to find out the stress developed, basically normal stress at point P. What is the normal stress developed at point P? You know that when the force is applied, this force have effectively two components. One is the direct force F, and another is the bending moment due to this force, right? Another will be the bending moment due to this force M, right? So due to these forces, there will be bending stresses as well as direct normal stresses. So using these two conditions, due to this force F, we have to find out the bending stress and tensile stress at point P point, right? So these are the options given to us. We have to select the correct option out of four choices. So let us solve this question.
this question contains a L-shaped bar at which a force is applied F, right? And we have to find out the stress is developed, axial stress is developed at point P. What are the stresses developed at point P? So this is a question of combined bending and direct stresses, because the effect of F, because it is at some eccentricity from the center, it has a distance of L minus B. So the effect of F is to elongate it by direct stress of F, and also there is a bending stress F multiplied by the distance L minus B. So there are two loading. The effect of F some eccentricity has two loading, F, that is direct stress, and the bending moment F multiplied by the perpendicular distance, right? So if I draw it separately, so you will get the effect of this is, I am making it somewhat wider to show the stresses also. Suppose this is our same thing, I am making here somewhat wider so that it is clearly visible to us. So at center basically two types of loading is there. One is direct stress, which is this F itself, and another is bending moment clockwise. This type of bending moment is there, that is F multiplied by the distance, and distance is L minus B. Total is L minus B, so L minus B. So this is basically moment, bending moment, that is M, that is equal to F multiplied by L minus B, right? So two type of loading is there, direct stress plus bending moment. So due to direct load, there will be direct stresses developed. Due to bending moment, there will be bending stresses developed. And at point P, you can see here, it will try to elongate it, bend it in this direction. So if you see it, the bending will be like this. If this is the initial axis, bending will be like this, right? It means that here at this fiber, tensile stresses will be developed. You can see here in this picture, you can see here the elongation like this. So upper part is elongated and lower part is compressed. So tensile stress will be developed in this fiber, at right fiber, and compressive stress will be developed at the left fiber, or you can say about the neutral axis or neutral layer. On the right side there will be tensile stresses, on the left side there will be compressive stresses. So at this point there will be compressive stress will be developed, right? And this is the point P, right? So compressive stresses will be developed on the right side of the neutral axis, right? Like this, right? So tensile stress, bending tensile stress here, bending compressive stress here, and there will be tensile stress due to force F, right? So we can see here there are two types of stresses will be developed. One is the direct stresses. This is the direct stress, which is tensile. These are the direct stresses, sigma d, and due to bending moment there is bending stress developed. due to bending moment, bending stresses will be developed. It is tensile. We are taking tensile in this direction, which is tensile and on the right fiber and compressive on the left fibers of the neutral axis, right? So this will be the stress condition. So this is the stress condition, right? Here it is compressive bending stress and here it is tensile bending stress, right? Compressive bending stress and tensile bending stress, right? Right? Compressive bending stress and tensile bending stress, right? So this is the condition of this case, right? So at P point, there are two types of stresses: direct stress and direct tensile stress and bending tensile stress, and that will be added up, right? And on left side, if there is any other point, suppose this point is Q, so at Q point there will be the stresses will be subtracted because it is tensile and it is compressive. It would have been subtracted, right? So how to solve this question? So in solution, we can write that sigma stress at point P will be direct stress, which is tensile, and some bending stress that is there, that is tensile bending stress, right? So sigma TB is tensile bending stress, right? So direct stress will be equal to direct stress, that is the force upon area, and what is given, force upon area is given. So area is 2b by 2b, so this is force upon 2b multiplied by 2b, so it will be equal to F by 4b square. So this is the direct stress, right? And what is bending stress? Bending stress can be obtained from the bending equation. We know bending equation m by I sigma by y E by r, and y is the distance of the fiber where we want to find out the stress from the neutral axis, and from the neutral axis the extreme fiber is P point is as the extreme fiber, that is this distance is b, right? So this distance is basically b, so y is equal to b, right? So sigma tensile bending stress sigma b is my by I, so that will be equal to m is FL minus B. So here sigma tensile bending stress will be equal to m is FL minus B, y is B extreme distance, that is B, upon I is, what is I, that is BD cube by 12, BD cube by 12, right? So B is 2B, D cube is 2B cube by 12, so this will come out to be, so it will be 12 by 8, so 12 by 8 will be 3 by 2, so it will be 3 by 4, basically 3 by 4. This is 8, 4, 3 and 4, 2, so it will be 4, right? 3 by 4, F, B and B cancel, so F L minus B upon B square, right? So sigma TB tensile stress is this, right? And total stress at point P will be equal to sum of direct stress and bending stress, so this will come out to be F by 4B square plus 3 by 4 F L minus B upon B square, and solve it, you will get the answer. This is L cube, B cube, solve it and you will get the answer. So you will get, after solving you will get F common multiplied by 3L minus 2B upon 3L minus 2B upon 4B cube. So this is the direct stress, that is F 3L minus 2B divided by 4B cube. So this is the answer of this question. The direct stress at point P is given by this equation, right? This is option number D. So this is answer and this is option D. Option D. So this option is the answer, option D.